Hello everyone, my name is Alena Krasnova and the topic to which I will introduce you today will be continuous integration. So let me describe on the high level what CI is. CI is the practice of automating the integration code changes from multiple contributors into a single software project. It's a primary DevOps best practice, allowing developers to frequently merge code into a central repository where builds and tests then run. Automated tools are used to assert the new code correctness before integration. Before CI was introduced, developers all over the world have faced with multiple issues during the development. Let's discuss the most pain points here. So, without CI, developers must manually coordinate and communicate when they are contributing code to the end product. The communication overhead in non-CI environment can become a complex and entangled synchronization chore. All mentioned about risks grow exponentially, and the engineering team and code base sizes increase. Um, it will make it harder for engineering to estimate time of delivery on request because the time to integrate new changes becomes an unknown risk. Now let's move on to benefits of CI process of your company. So CI enables organizations to scale in engineering team size, code base size, and infrastructure. By minimizing code integration, bureaucracy, and communication overhead, CI helps build DevOps and agile workflows. Faster feedback on business decisions is another powerful side of CI. Product teams can test ideas and iterate project designs faster with an optimized CI platform. CI improves engineering communication and accountability, which enables gather collaboration between development and operation in a DevOps team. Let me turn now to the description of the details of CI process. The default CI process consists of several parts. First and foremost is the version control system. It can be any system which your team prefers, uh, distributed like Git or centralized like CVN or so on. It's obligatory that all changes of source code must be done through the version control system. When some changes is made, the CI build server will be triggered and some job will start to execute. CI jobs typically perform several tasks. So it's restore packages for a project, run builds of your code base, run unit or integration tests, and perform static code analysis. As soon as all those steps are completed, the job will give the feedback of the new source code changes. Are they acceptable or not? If yes, the developer can check in code or merge pull request. If not, some code fixes must be implemented. Currently, there are a lot of CI tools on market from different vendors. All of them share exactly the same concepts, but the some specific way. Most popular tools will be the following. So it's Jenkins, Azure DevOps, Bamboo, TeamCity, and Travis CI. Here are the examples of UI for these tools. On the screens, you can see build and release jobs. The main idea here is just to demonstrate that all tools share the same concept. So let's look now at the different strategies on the version control system integration with CI pipeline. There is one thing which made those strategies similar. CI is typically configured on a single. Here are the most popular. All of them have their pluses and minuses. So it is trunk-based Git flow, GitHub flow, and GitLab flow. As an illustration for trunk-based development, let's take a look at the picture. Here we can see that there is a single branch which called trunk. All developers should commit frequently to this branch on the daily basis, and this is the main integration point. There are now other branches except release ones. In case when there is some fully implemented feature, developers still push changes to trunk branch and disable feature using feature toggle. CI job will be triggered on each commit to the trunk branch. Um, let's look now at a completely different scenario in comparison to the previous one. The main difference here is that in Git flow model, developers are working in separated branches. After feature implementation, they create pull request from feature branch to dev. And CI job is typically configured of those PRs. There are no direct comments to dev branch, only pull requests from feature branches. Besides feature branches, there are other ones which participate during the release. Release, master, and hotfix. So GitHub Flow. This flow is a simplified model that the previous one. Developers are still working in a feature branch and made PRs into master branch, which will be main integration point here. CI will be triggered on PR. There are no other branches except feature and master. Whatever branching strategies was chosen, the next step is to perform some quality gates around new changes. It needs to be mentioned that there is no unified approach of which steps are required or not. Let me describe you the most popular ones. So it is pull request code review, code build, tests, and static code analyze. Last but not least is the end-to-end demonstration of how CI process in connection with GitHub or Git flows. At first, some developer completed features in his feature branch and wanted to integrate his changes. He made pull request from feature branch to dev or master. CI server triggers on this pull request and executes build job. Build job starts executing all configuration steps, which includes install packages, run build, run tests, integration or unit, and perform static code analyze with some tooling depending on your language. For example, yes, lint, just test coverage, or, and so on, and gives feedback. Each team member can see results of the CI job being successful or not. If yes, team members can perform code review and approve new changes or reject with comments. In case when PR was approved, developer can merge code. In case when changes were requested or the build was not successful, developer must implement some fixes to update PR, and the whole process will start from the very beginning. Thank you for watching.